we are going to discuss today's topic as rank of matrices. What are elementary transformation? I can interchange any two rows, I can multiply any row, any column with scalar, or I can make a change in row with any another row, multiplying a scalar and adding it to that particular row in which I need to make a change. You would just completely row reduced into echelon form. Just reduce it into an echelon form and count the number of non-zero rows. That would be comparatively easy. Rank of A is M and rank of B is N. Then rank of AB is less than equals to minimum of M. Hello students, welcome back to our YouTube channel Geeks for 𝐂𝐸𝐬𝐿, Computer Science and Data Science. So we are continuing a series in which we are going to discuss today's topic as rank of matrices. Till now we have covered three topics, that is basics of matrices, then we have discussed types of matrices, and later on we have discussed determinant. So in this video we are going to discuss rank of a matrix. So in last video we have seen that how to find out determinant of a matrix, and we also have seen properties of matrices. Now the question arises that what is rank of a matrix? Now to understand this rank of matrices, first we have to understand some elementary operations or elementary transformation. These elementary transformation we already have worked on. Our determinant, right? Not all the properties, but some of the properties, some of the transformation we have used. So what is it? That elementary transformation means that I can transform the matrix using these operations. And what are those operations? That I can interchange any two rows or any two columns. That's the same thing I have done in determinant, but I have said that the determinant gets multiplied with a negative sign, right? Now, multiplication of the ith row by a non-zero number k. I can multiply any scalar with a number k. I can do the same thing in determinant as well, but the determinant gets multiplied by k, right? So that means I can interchange any row. Let's suppose we have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to find out I have to interchange any two rows. Let's suppose I am going to interchange R1 with R2. So what would it become? 4, 5, 6. This whole row 2 become row 1 and whole row 1 becomes row 2. 1, 2, 3. And the last row remain as it is because I haven't applied any transformation on row 3. Right? Now next thing is I can multiply any scalar. Let's suppose if I want to multiply any scalar, R3 tends to 2R3. That means I can multiply row 3 with 2. Now what do I mean by multiplying 2 with row 3? That means first and second row remains as it is, 4, 5, 6, 1, 2, 3. But the second row gets multiplied with 2. That means 2 7s are 14, 2 8s are 16 and 2 9s are 18. So this whole row third row gets multiplied with 2. That is my second transformation. Third transformation is addition of k times to the jth row to the ith row. That means I am making a change in the ith row with the help of rj row by multiplying k with rj. That's the same thing we have done in determinant, but we have said that it does not change the determinant. These two change the determinant. It would multiply with minus sign, it would multiply the determinant with k, but these two this third transformation does not make any impact on my matrix determinant, right? So what is the operation? Let's suppose I am writing here R1 tends to R1 minus 4R2. I am applying this operation in general. I am making a change in R1 with the help of R2. What would I get? So second 4 minus 1 into 4, that would be 0, because this is 4 minus 1 into 4, that would be 0. And then 5 minus 2 into 4, minus 8, 5 minus 8, minus 3, and 6 minus 3 into 4, 6 minus 12, that would be minus 6. Everything else remains as it is. 1, 2, 3, 14, 16, 18. Right? So these are called as elementary transformation. What are elementary transformation? I can interchange any two rows, I can multiply any row, any column with scalar, or I can make a change in row with any another row, multiplying a scalar and adding it to that particular row in which I need to make a change. Right? These three are my elementary transformation. Now with the help of elementary transformation, I have to convert a matrix into row reduced echelon form. Now the question arises that what is this row reduced echelon form, right? Because in row, with the help of row reduced echelon form, we find out rank of a matrix. So let's see what is row reduced echelon form. Now when I talk about row reduced echelon form, just a minute, यहाँ पे discuss करते हैं. When I talk about row reduced echelon form, so what row reduced echelon form says, it says that all the zero rows, and what do I mean by zero row? In which all the entries are zero. All the zero rows comes at the bottom of the matrix. That means all the zero rows we have at the bottom of the matrix. If I have any row in which all the rows are zero, all the values of a row are zero, then I'll take it to the bottom, right? I'll write down at the bottom. And what would I do? Let's suppose I have this matrix 1 2 3 4 0 2 4 5 0 0 3 1. I have this matrix. Now what would I do? Now in each row find first non-zero entry. This is my first non-zero entry. This is my first non-zero entry. This is my first non-zero entry in a row. And number of zeros before this non-zero entry. Number of zeros before this non-zero entry should be in an increasing manner. Number of zeros before 1 is 0. Number of zeros before 2 is 1. Number of zeros before 3 is 2. So that means these zeros should be in an increasing manner. So first what would you do? In a matrix, you would find out first non-zero entry. You would find out first non-zero entry and you would count number of zeros before all the non-zero entries. And if it is in an increasing manner, then it is your row reduced echelon form. This is my row reduced echelon form. Some people might make this value first non-zero entry as 1, but here it is not required, so we will not convert it into 1. Right? So you can also call it as pivot entry, but some people say that to make it pivot you have to make it 1, but right now it is not required, so we are not making first non-zero entry as 1. Right? So that is the same definition we have for row reduced echelon form. What it says, a matrix is said to be row reduced echelon form if non-zero rows occur above the zero rows. So that means all the zero rows lies at the bottom of the matrix. Right? If I have 2, 3, 4, number of non-zero rows lies at the bottom of the matrix. Number of zeros, now see what it is saying, number of zeros preceding the first non-zero element. Number of zeros preceding the first non-zero element in a row is greater than the number of such zeros in preceding row. Or I can say that number of zeros before first non-zero entry in a row should be an increasing manner as we move down to the matrix. Can I say that? Right, that would be true. Now let's see this example. Now I have to check this example. Is it a row reduced echelon form or not? So I'll say that this is my first non-zero entry. This is my first non-zero entry in this row. And this whole row is 0. So this become, so I have 1 0 before this non-zero entry. I have 3 0. It is in an increasing manner. So it is row reduced echelon form. I'll go back to this. Now to check this. This is first non-zero entry. This is first non-zero entry. This is whole row 0. So number of zeros before this first non-zero entry here is 0. And here it is 1. It is again in an increasing manner. Right? So it is in row reduced echelon form. Similarly this one. Now let's check this one. Now here 0 row lie above the 0 rows. 0 row lie at the top of the matrix. So it is not a row reduced echelon form. It is not row reduced echelon form. But using elementary transformation, I can convert any matrix into a row reduced echelon form. Any matrix I can convert it into a row reduced echelon form. Now let's check this matrix, that how I am going to convert this matrix into a row reduced echelon form. Right? So what I can do, if I'll interchange first and second row, because I have to take this particular row at the bottom of the matrix. Let's say I'll do that R1 interchange with R2. What would I get? 1 1 0 0 0 0 and 0 0 1. Is it row reduced echelon form? No, because this 0 0 should at the bottom of the matrix. R2 interchange with R3. 1 1 0 and 0 0 1 and 0 0 0. Now it is in my row reduced echelon form. So any matrix you can convert it into a row reduced echelon form. Any matrix you can convert. Now the question arises that, like, can you convert this matrix A into row reduced echelon form? Let's try this. This is right now not in row reduced echelon form because number of zeros before the first non-zero entry should be in an increasing manner. Here 1, 2, 3, we have all the entries here. The entry before 1 is 0, entries before 2, 0 entries before 2 is 0, it is before 3 is 0. So that means what I need to do, I need to make these entries as 0. I need to make this entry and this entry, both the entries as 0, because that would help to increase number of zeros, because 1 se pehle I have 0 zeros. So I have to make this entry 0 so that first non-zero entry yahan pe aaye. Right? So what would I do? I'll make zeros before after 1. Right? So what would I'll apply the operation? How to make this 2, 0? Now you cannot do R2 minus 2 directly. Right? Because that's not the kind of elementary transformation we know. We know 3 kinds of elementary transformation: row interchange, multiplying with a scalar, or making a change in this any row with the help of another row multiplying a scalar. Right? So what I can do here, can I write down this operation R2 tends to R2 minus 2R1? Now you would see here what would happen in this matrix. 1, 2, 3. What would happen? R2 minus 2R1. You would make this value 0. 2 into minus 2 into 1. That would be 0. 3 minus 2 into 2. That would be minus 1. 4 into minus 3 into 2. That would be minus 6. 4 minus 6, you would get it as minus 2. Now there would be a third row, 3, 5, 7. Now you have to make this value 0 as well. Otherwise you have first non-zero entry 0 and 1 entry, 1 0 entry, but in this you do not have any 0 entry. So make this 0 as well. What would I apply the operation? R3, and make sure that you are to make these two values 0, just use row 1. For first column, to make entry 0 in first column, you would use first pivot entry. R3 tends to R3 minus 3R1. Right? I'll apply the operation. R3 minus 3R1, 3 minus 3, that would be 0. 5 minus 3 into 2, that would be minus 1. And 7 minus 3 into 2. 3 2s are 6, 7 minus 6. That would give me 1. Right? But again, if you would see that this entry, number of zeros before this entry would be 0, number of zeros before this entry would be 1, number of zeros before this entry would, here it is 1. Now you have to make this value 0, so then it would be an increasing manner. So you would apply the operation R3 tends to R3 minus R2. What it would become? This matrix would become 1, 2, 3, 0, minus 1, minus 2, and this would be 0, 0, and this would be 3. So this is my matrix. So this is a row reduced echelon form, and you can check that all the we do not have any 0 row, so we do not have to take care of that. But number of zeros before this first non-zero entry is 0. Number of zeros before this first non-zero entry is 1. Number of zeros before this first non-zero entry is 2. So this is my row reduced echelon form. Just check the calculation by yourself as well. Row reduced echelon form. Right, this is my row reduced echelon form. Now the question arises that what is rank of a matrix? Right, we have studied elementary transformation, we have studied row reduced echelon form. Now what is rank of a matrix? Rank of a matrix, it is basically, it is number of non-zero rows, number of non-zero rows in a row reduced echelon form. So rank of a matrix is a number of number of non-zero rows in a row reduced echelon form. So if we have a 0 row, we'll remove that, otherwise that would become rank of a matrix. Rank of matrix is a number. So here number of non-zero rows. Now in this question, if I'll discuss what would be the rank of this matrix, let's suppose this is a matrix A, then what would be the rank of the matrix A? I'll write down either RANK rank of A, or we also denote with this row sign, rank of A. So rank of A here would be 3, because we have 3 non-zero rows. And what is the meaning of non-zero row? If in any row I have at least one entry non-zero, that would be a non-zero row, right? Now we have some more example. What would be rank of this matrix? Rank here would be number of non-zero rows. We have 2 rows which are non-zero. Rank here would be 2. Here also rank is 2. And also when I have, right now I was not able to tell the rank of a matrix, because rank of the matrix you can only take rank of a matrix in a, like, it is a number of non-zero rows in a row reduced echelon form. So it is row reduced echelon form. Now in this matrix you can say that for this matrix rank would be 2. You can say only rank when you have row reduced the matrix, otherwise you cannot tell that. It is number of non-zero rows in a row reduced echelon form of the given matrix, right? So that's how you find out rank of a matrix. Now there is another definition which is using minor. What is a minor here? Let's suppose we have a 2 cross 2 matrix. I have 1 2 3 4. This is a matrix. So what would I do? First I'll find out determinant of 2 cross 2, right? Determinant of 2 cross 2. So this is my, how many 2 cross 2 minor are possible? From this only 2 cross 2 matrices are possible. So 2 cross 2 determinant are possible. So we have 1 2 cross 2 minor. Also I can find out for 1 cross 1 minor would be 1 cross 1 minor. This is 2 cross 2 minor, right? What would be 1 cross 1 minor? 1 le lo, 2 3 4, right? These are the minors. Similarly, if I have a 3 cross 3 matrix, let's say I have 1 2 3 4 5 6 2 1 and this is my matrix, right? So if I'll take 3 cross 3 minor, 3 cross 3 minor, this is the matrix itself. Determinant 1 2 3 4 8 0 2 1 3. Now I'll take 2 cross 2 minors out of it. 2 cross 2 minors would be okay, yeah, what would be 2 cross 2 minors? You would take all the 2 cross 2 matrices possible. 1 2 4 8, just a minute. Yeah, 1 2 4 8. I'll take 2 3 8 0. I'll take 4 8 2 1. ठीक है, बहुत सारे माइनस पॉसिबल होंगे. सिमिलरली हाउ मेनी 1 क्रॉस 1 माइनस पॉसिबल? देयर वुड बी 9 1 क्रॉस 1 माइनर पॉसिबल. आई थिंक 2 क्रॉस 2 माइनस यू वुड हैव like just check it how many 2 cross 2 minors you would have. Similarly you would have 1 cross 1 minor. So now you know how to find out a minors. Now I need to check that how to find out rank using minor. How to find out rank using minor. Just a minute. So what would I do? I am writing here. So first of all, let's suppose you have a I am just finding out rank using minor. Rank using minor. So for that, what would you do? First, you would find out the determinant. If you have to find out rank of 2 cross 2 matrix, then you would find out determinant of 2 cross 2 matrix. If that determinant would be 0, if that determinant would be non-zero, first of all, if that determinant would be non-zero, rank would become 2. If that determinant would be 0, then you would go for 1 cross 1 minor. So you would check that each of the minor, if any one of the minor should be non-zero, rank would become 1. If all of the minors would be 0, then rank would become 0. right? So let's suppose we have this matrix. For this matrix, because determinant is non-zero, so rank is 2. Let's suppose if I have taken the matrix 1 2 2 4, if I have taken this matrix, obviously if I'll find out the determinant is 0, so I'll go for rank would not be equals to 2. I'll go for 1 cross 1 minor. I'll take one entry 1, so it is a non-zero value. So that's why you have rank here as, for this rank here as 1. Similarly, for 3 cross 3 matrix, what you need to do? You first need to find out the determinant of the matrix. If determinant of matrix is 0, then if non-zero, then rank is 3. If it is 0, then you would check for 2 cross 2 minor. If all 2 cross 2 minors, determinant would be 0. If one of them is non-zero, rank would be 2. If all of them would be 0, then rank would be 1. Right? Like I'll show you. And rank would be 0 only when you have a null matrix. Let's suppose you have this matrix 1 2 3 4 1 0 2, and let's say इसको 8 ले लो, इसको 1, इसको 0. We have this matrix. If I'll find out the determinant of this matrix, what would I get? Let's find out determinant of this matrix 3. मैं इसके corresponding expand कर रही हूँ. 4 minus 16 minus 36 not equals to 0. So rank would be 3 here. Rank is 3 here. So rank is 3. I can directly say that rank is 3. But when I'll take, let's suppose we have this matrix 1 2 3 2 4 6 0 1 0. We have this matrix, and let's say I'll find out the determinant here. You would get the determinant here as 0. You would go for 2 cross 2 minor. You would check 1 2 2 4. You would get 0. You would get check 2 3 4 6. You would get 0. But likewise this you have to check all the 2 cross 2 minor. अगर पहले दूसरे 0 मिल रहे हैं, you do not need to stop here. I'll check for another one. 2 4 0 1. 2 4 0 1. This is not equals to 0. So that's why rank is equals to 2. So the problem with this minor definition of rank is, rank using minor is that you have to check each of the entry, and that would really get lengthy. Instead of doing that, you would just completely row reduced into echelon form, just reduce it into an echelon form and count the number of non-zero rows. That would be comparatively easy. Now let's see some questions. Let's try to find out. Okay, this though we already have solved. Just a minute. We already have solved 1 2 3 2 3 4 3 5 7. We already have found out a rank for here. Rank I got here as 3. Rank we got it here as 3. Let's see one more question. If I need to find out rank is here, I need to row reduce it. What would I do? First I can see that it has maximum number of zeros. I can take it to the bottom. I can write down R1 interchange with R3. I'll get 3 1 1 9 3 5 and 0 0 minus 3. Now I'll make this entry 0. Right, that is my next task. R2 tends to R2 minus 3 R1. Sorry. What it would become? 3 1 1 0 0 5 minus 1 5 minus 3, that would be 2 0 0 minus 3. Is it in row reduced echelon form? No, it is not in row reduced echelon form, because number of zeros before this non-zero entry is 2. Number of zeros before this non-zero entry is again 2. So that is 2 and 2. So that's why you have to increase it, or you would make this entry 0. So what would I do? इसी की just above वाली से इसको 0 बनाते हैं. R3 tends to R3 plus R2 2 by 3. Right? So, sorry, 3 by 2. I'll get the matrix as 3 1 1 0 0 2 and 0 0 0. So here number of non-zero rows, this is non-zero, this is non-zero. So rank here would be 2 here. Rank would be 2. Right? So from now onwards we are not going to use the definition minor. If in case they mentioned about minor in a question, then I am going to get to that concept. Otherwise I am going to use number of non-zero rows in a row reduced echelon form for rank. Let's see more questions. Okay, so let's see, discuss some of the properties. What they are saying, if A is a null matrix, then rank of the matrix is 0. If we have an identity matrix, then rank is n. And if A is of order m cross n, then rank of A would be minimum of m, less than equals to minimum of m comma n. So I can say that rank of A is less than equals to m, and rank of A is also less than equals to m. And I told you, if A is of order n cross n and determinant A is non-zero, then rank would become n. We have already seen that in minor definition. Rank of A is m and rank of B is n, then rank of AB is less than equals to minimum of m comma n. That means if you would multiply any two matrices AB, then rank of AB would be less than equals to minimum of m comma n. It cannot be greater than m comma n minimum. A is a non-zero column vector, B is a non-zero row matrix, rank of AB is 1. You would see that if you would multiply a column and a row, you would get only the multiples of all the vectors in the matrix, and they would become 0 when you would apply row reduced echelon form. You can just check this by yourself. Rank of a skew symmetric matrix cannot be equals to 1. That would be true because we have 0 entry here, 1 minus 1, to make it a skew symmetric. So either it would be 0, it cannot be 1 here, right? And also one more thing, I am writing one more property here, that let's suppose A is a matrix of order m cross r and it has rank r. B is a matrix of r cross n and B matrix also has rank r. Then AB matrix has order m cross n, but it would also has rank r. It would have rank r. AB has, or you can write down, ऐसे मत लिखो ना, you can also write down that m cross p and B is p cross n. Then A has rank r, B has rank r. If both have same rank, then it would be rank r. आर ही लिख लो इसको. आर लिख लो अभी, ठीक है. It would have rank r. M cross r and B is r cross n. Then it would have rank r. Right? Now let's see more questions. Let's see this question. Suppose the rank of a matrix is 2 for some real numbers A and B. Then what would be the value of B? So they are asking for a value of B. So we know one thing, to find out rank of a matrix, I just need to row reduce the matrix. So what would I do? I'll start row reducing. I'll apply the operation to make it 0. R2 tends to R2 minus R1. And for this A value, that I also make it 0. First, right now I am considering A is not equals to 0. Then I can multiply it any row, na? R3 tends to R3 minus A R1. I am considering A not equals to 0. R2 minus R1 and R3 tends to R3 minus A R1. What would I get the matrix? 1 1 2 2 0 0 1 minus 2 minus 1 3 minus 2 1. This would be 0. This would be B minus A, and this would be B minus what it would be, B minus 2A, and then it would be again 1 minus 2A. This is a matrix I get after row reduction. Now one thing you would notice here, that if you would not take B is equals to A, if I am not taking B is equals to A, I'll interchange second and third row. Let's suppose I am taking B not equals to A, and then I'll interchange R1 interchange with R3. Sorry, R2 interchange with R3. What would I get? 1 1 2 2 0 B minus A, B minus 2A, and 1 minus 2A. 0 0 minus 1 1. So you can see that this is first non-zero entry, this is first non-zero entry. It is in row reduced echelon form. Rank would be 3, but they have said that rank would be 2. So this would be incorrect. So that means B should equals to A. B would equals to A here, I have to consider that A is equals to B. So if I'll consider A is equals to B, then this matrix would become 1 1 2 2 0 0 minus 1 1, and this would become 0 0 minus A, and it would be 1 minus 2A. Right, I have just substituted B is equals to A here. Now they are saying that B equals, first of all I have to make this value 0. Let's make this value 0. So I can apply the operation here, R3 tends to R3 and minus AR2. So what would I get? 1 1 2 2 0 0 minus 1 1 0 0 minus A plus A, that would be 0, 1 minus 3A. Now I have given that the rank of the matrix is, rank of matrix I have given here is 2, right? Rank of matrix here I have given is 2, so there should be 2 non-zero entries. This 1 minus 3A has to be 0. So when I'll take 1 minus 3A 0, I'll get A is equals to 1 by 3 and A is equals to B. So then B equals to 1 by 3. So option D is correct here, right? So here option D is correct. So that's how we solve the questions based on rank of a matrix. So practice more questions, just go through, guys, if you have to practice questions, you can just go through the book Linear Algebra by Gilbert Strang. And if you have any doubt or any confusion, just let me know in chat section. We can discuss there as well, right? Okay, so I'll discuss it in the next video. Okay, so yeah, that's all for today's lecture. We are going to continue in next lecture, in which we are going to discuss system of linear equation. We are going to start system of linear equation, and then in that we are going to discuss homogeneous and non-homogeneous system of linear equation. But make sure guys that you would practice questions as well from the book. Okay, so yeah, that's all for today's lecture. Thank you.